Okay, think we're about good to start here. Hello everyone, my name is Dan. I do these tutor sessions every week where I go over SAT, ACT, and AMC math questions and whatever the community submits. While you're here, you can check out my TikTok, other helpful videos, resources at explore.danstestprep.com. And I also have a weekly newsletter where I send out like a SAT tip every week. Other than that, the way this session is going to go is we're going to go start with our warm-up SAT problems, and this is special because we've got some digital SAT problems today. We'll probably go into our ACT problems, and then we'll finish off with the hard problems that I got from the AMC, the American Mathematics competitions, and just a couple community questions, including I have 2 more slots open for you guys to submit questions if you'd like to go over that. Okay. So our first warm-up question, this is from the digital SAT. What is the minimum value of the given function? Let me paste it in to the chat just in case. Right here. Digital SAT, in my opinion, is a little bit easier. Maybe not in terms of the content difficulty, but definitely in terms of the test taking experience. If you prefer a paper test, then you still have a chance to take that this fall, or you can take the ACT, but the SAT is definitely going digital. For this was one of the practice problems from the digital SAT questions from the College Board. To find the minimum value of the function, I see some answers already. 55. 55 would be correct. Easy way you can do this? Well, on the digital SAT, you literally have a Desmos graphing calculator, so you could graph it if you want. But for this one, if we look at the x squared term, we know that x squared has to be greater than or equal to 0. And if you think of the graph x squared plus 55, it's going to be a parabola that's raised 55 units up. So from either of those, we can draw the conclusion that the minimum value is going to be here, right at y equals 55. If you don't want to graph it out or you don't know what that looks like, you can use this fact that x squared is greater than or equal to 0 because it can never be negative. So you could just plug in 0 here, get g of 0 is equal to 0 plus 55. Anything else is just going to go higher. Okay, so next problem here. Let me paste it in chat. I see we got a question submitted here, so I'll go ahead and add that to the bottom, and we'll go over that later after I get through my main questions. There we go. Okay. So the one I sent says figure A and figure B are both regular polygons. It means they're just polygons or shapes that have the same side length for each side. The sum of the perimeter of figure A and the perimeter of figure B is 63 inches. So sum. The equation 3x plus 6y equals 63 represents this situation where x is the number of sides of figure A, x corresponds to figure A, and y corresponds to figure B. Which statement is the best interpretation of 6 in this context? Okay, so we know that the perimeter is 63. And if I draw this out, maybe it makes it a little bit clearer. Let's just draw a regular polygon that has x sides, could be anything, and another polygon that regular polygon that has y sides. 3x means, well, if we have x number of sides, 3 times x would mean every side length is a length of 3. So like here it would be 3, 3, 3, 3. 6y, well, we know that y is related to figure B. So 6 multiplied by y means that every side, every one of these y sides has a side length of 6. So the only one that makes sense in this context is that each side of figure B, which relates to y, has a length of 6 inches. It's not that the number of sides of figure B is 6. We know that the number of sides was y, so we can definitely cross out B. It's not relating to figure A because that was related to X. Again, not related to figure A, so that one should be pretty easy to cross out. Okay, next question we have here is system of equations. Hopefully you guys can recognize that this is a system of equations problem. We have that store A sells raspberries for $5.50 per pint. Store A, $5.50 per pint, raspberries, and blackberries for $3 per pint. So I'm going to say for store A, we have 550 times number of raspberries plus 3 times the number of blackberries equals something. For store B, well, we know that store B sells raspberries for 650 per pint, 650R, and sells blackberries for $8 per pint. And that should equal another number. And here it tells us that a purchase of raspberries and blackberries would cost $37 at store A or 66 at store B. So let me fill in those numbers as our final cost here. So we have our two equations. You could solve this with different methods, like you could use elimination, you could use substitution, and if you're taking the paper SAT, that's what I would recommend you do, because usually these are on the no calculator section. But with the digital SAT, I would honestly just recommend graphing these. Because if you, instead of R and B, of course, you would just use like X and Y, because that's what Desmos uses. But let me show you how we could do this in Desmos pretty easily. So this is actually built into the test when you're taking it on the Blue Book app. We could do 550x plus 3y equals 37. And our next equation would be 650x plus 8y equals 66. And you could see that it intersects at 4, 5. Actually, let me even paste that in to the document that I have open right now. Copy that. Paste that right there. This point of intersection is a solution to the system of equations, and it's at 4, 5. So that means x equals 4, which is equal to the number of pints of raspberries. Y equals 5, that corresponds to the blueberries, or blackberries. And since the question is asking us about blackberries, we're going to take the y variable. So it would be 5 pints of blackberries were in this purchase. All clear, I hope. And the last one we have here, function h is defined by h of x is equal to a to the x plus b, where a and b are positive constants. I'll paste it in as well. The graph of y equals h of x in the xy plane passes through the points 0, 10, and -2, 325 over 36. What is the value of AB? Okay, so usually when I see something like this, you can maybe get AB to show up in the question, but I don't think that's possible here. So let's solve for A and B separately. If I plug in 0, 10 into my equation, I will get h of 0 equals 10, which equals to a to the 0 plus b. So 10 is equal to 1 plus b, or in other words, b is equal to 9. And then we need to find the value of a. So we could now plug in our second point. So we get that h of -2. Let me do it in a different color. H of -2 is equal to a to the -2 plus 9. That b value that we just found was 9. And we know that this is equal to 325 over 36. I see we've got some answers, so let's make sure we can get to that point. We'll subtract 9 from both sides here. -9 and -9. But also note that 9 equals to 324 over 36. And the way I got that is just multiplying by 36 on both the top and the bottom here. If we have something like 9 divided by 1, which is equivalent to 9, I could rewrite this as a nice fraction with a denominator of 36. So really this is like saying a to the negative 2 is equal to 325 over 36 minus 324 over 36, which is equal to 1/36. And then a to the negative 2, we flip that negative exponent to make it positive. So it's actually 1 over a squared is equal to 1 over 36, which now you should see that a squared equals 36 following this statement. Which means that if we take the square root of both sides, a equals plus or minus 6. I don't see any negatives though, so we're just going to take the positive answer. So all in all, we get a equals 6, b equals 9. A, b would be the product of those two. 6 times 9 is 54, which would be answer choice C. So Oliver, you are correct. Hopefully those were all clear. That's our SAT warm-up. Do you guys have a preference for going over the AMC questions or the ACT first? I don't see one. So I'll go through the ACT since it's the next test prep thing, and I guess a lot of you people here are here for test prep. Well, I guess AMC is also test, but I mean like high school test prep, like college admissions. This ACT problem is asking us what is the value of the expression log base 6 of 36 times log base 3 of 9. See if you guys can take a second to figure out what that's asking us. Alright, I see we already have an answer. That was very quick. So I'll show you guys, you must be good with logs. I'll show you guys how I would do this one. I would start by taking log base 6 of 36 and just really rewriting it in terms of exponents to make sure I know what I'm doing. To me, log base 6, or I would write the base of 6 down here, figure out what exponent do we need to put here to get to the answer of 36. So I could write this as like 6 to the x equals 36, which would mean that x equals 2, right? We need 6 squared to get to 36. And same thing here, it's 3 to what power equals 9. That's essentially what this logarithm is asking, kind of like the different way of writing exponents. But the exponent is the solution in this case instead of what we're evaluating. And here it's also, we need 3 squared to get to 9. So then if you take these two expressions and you multiply them together, it's just 2 times 2, which is 4. So that's also pretty simple, but only if you're familiar with your logarithm rules. 37 is a nice one as well, and I think some of the digital SAT problems are looking like this as well. It's all about translating math into words, and an easy way to do that, I'll show you right now. If we have something like one number or a number, I could just mark that as an unknown variable, like x. If we have the word is, that just means equals. 25% I'm going to write as a decimal at 0.25. Of means multiply, and the second number could be y. It's just some number. So what I've done is converted this first sentence into math. One number x is 25% of another number. And the second number, y, is 70% of a third number. Let's call that z. Then we're trying to relate the first number is what percent of the third number. So we need to eliminate the second number and just get get it in terms of x and z. No y. So what I could do is just substitute. X is equal to 0.25. In place of y, I have an alternate definition, which is 0.70 times z. And if I evaluate this through, 0.25 times 0.70 is just 0.175z. So, of course, this is going to translate to x is 17.5% of z. That should make sense because if x is 25% of y and y is 70% of z, x is going to be much smaller than z, so it's got to be 17.5%. Can't be anything really large like 95%. That would be a mistake from adding these two percents together. So you can always check your work like that. Alright, this next one I think is pretty interesting. Another ACT problem. A rectangle with an area of 30 square inches has a length and width in inches that are both integers. Area is 30, length and width are integers. Which of the following cannot be the perimeter of the rectangle? Okay, so if area equals 30, I can think of factors for the length and width that would multiply to 30. Right? The length could be 1, the width could be 30, length could be 2, width could be 15, length could be 3, could have 10 here, 4 and 5, sorry, 5 and 6 could be another factor. Dang, you got that one quick. Answer 60. That is correct. I'm interested in seeing how you did that, but I'll show you how I would methodically go through this one. With all of these, you're only going to have 4 possible combinations for a valid perimeter. And if I make another column for the perimeter, let's see, so like perimeter is always equal to twice the length plus twice the width. You could see that if I draw out a rectangle, right? This right here, for example, could be like 130, 130. We have 2 copies of the length, 2 copies of the width. So in this case, the perimeter equals 62. In this one, it's going to be 4 plus 30 is 34, 6 plus 20 is 26, and this one is going to be 10 plus 12, which is 22. So when you do this and you calculate the perimeter for each possible case, you can rule out these because they're all valid options and you're just left with J. It is not possible for the perimeter to be 60 because we don't have any valid integer combinations that could get us to that area or that perimeter. Any questions so far? I have one more ACT problem after this. I'll put it in the chat. Can't see the stream. Maybe try rejoining, refreshing. I am also pasting in the questions. Okay. So this one is a pretty cool one. It's in the standard xy coordinate plane, the 3 lines with equations y equals 3/5 x minus 3, y equals negative 2/5 x plus 2, and x equals 0 bound a triangular region. We have a triangle. And we want the area in square coordinate units of that triangular region. It's pretty nice that they give us a grid here, because I could start graphing. The easiest one is going to be x equals 0, right? X equals 0 is just this vertical line. And maybe there's another color that's better here, actually. X equals 0 is just this line that is the y-axis. That's our x equals 0 line. Dang, Oliver, you're quick. I'm still drawing it out. But that is correct. y equals 3/5 x minus 3. Well, if I go down 3 and I start drawing my slope of 3/5, it would be rise 3, run 5, or up 3 over 5, which would put me right here. And I could draw a line there as well. Oh no, I'll just sketch it. And then the last one is negative 2/5 x plus 2. Well, that one's just going to be starting up at 2. We go down 2 over 5, which would bring us over to this point as well. So now we've got our triangle. Remember, the area of a triangle is just base times height divided by 2. And if we count the number of units here, the base is 5 units. The height is also 5 units, right? Because we found that out from the slope pretty easily. So the area here would just be 5 times 5 over 2, which is 25 over 2, or simply 12.5 square units. Let me actually go into some of the community problems here real quick. I saw one submitted earlier that was some algebra that we can do as a quick little exercise. This one looks like we're just evaluating exponents, right? So 6 times 2 to the 0 is just 1. 6 cubed is 216. 6 to the 0 is 1 times 2, and then 2 squared is 4. So maybe I can try doing this as a mental math exercise. I know I would group 2 times 4 as 8, and then 6 times 8 would be 48. So then we have 48 times 216. Now I'm not that good at my 2-digit and 3-digit multiplication, so at this point I'd probably have to write it out like this. 8 times 6 is 48. Then we just have to do it out, and 6, 8, I'm gonna get 8, 6, 3, 1,368. Alright, someone in the chat, Oliver, you were on a roll. You got the same answer, so I trust you. I think that's correct. And then this one, okay, well, h to the 0 is just equal to 1, so this is just k to the 8th, put simply. I like that. Let's do a little bit of a harder exponential problem. Here's one that I also saw in the math chat. It's step 1, solve the exponential equation. Oh, and let me put it in the chat if you guys can't see. This was in the math help earlier today. Solve the exponential equation, explain how you made the connections between the left side and the right side, and can you rewrite the problem? Okay, so for solving, I know that the value of 1 is the same thing as 2 to the 0th power. That's the only way I can get 1 with a base of 2. But the useful thing about this is if I write 2 to the x to the 3rd minus x is equal to 2 to the 0, we can actually equate these exponents to each other. It makes it much easier, right? We have x cubed minus x is equal to 0. And then we can further simplify this as x, factor out the x to get x squared minus 1 equals 0. And it's kind of just some algebra at this point. So the possible solutions for this, it could be x equals to 0 or x squared minus 1 equals to 0, which implies x squared is equal to 1, or that if we take the square root of both sides, x can be equal to plus or minus 1. So x can be equal to -1, 0, or 1. Explain how you made the connections between the exponents on the left side with values on the right side. Well, you guys just saw I rewrote 1 as a base of 2, specifically 2 to the 0th power. And can you rewrite the problem as shown below? Yes, because we can use the exponent rule that if we have two of the same base dividing each other, we can subtract the exponents in the bottom and just rewrite this under one base. Or that a to the b over a to the c is the same thing as a to the b minus c. Alright. I have room for one more question if you guys want to submit anything, but I'm going to go over the AMC questions now, the American Math Competition. So here's our next one. Which of the following describes the set of values of a for which the curves x squared plus y squared equals a squared and y squared equals x squared minus a in the real xy plane intersect at exactly 3 points? Okay. I recognize that this first equation is the equation of a circle. This one is a parabola, but still that doesn't really give me much insight except that I'm looking for a shape that kind of looks like um, this. If I can draw it, intersects here, here, and here. 3 points. Because you could also have a pretty wide parabola that intersects at 1 point, or you could even maybe have 0 intersection points, or 2. So what I would do to start off is, since I'm given this alternate definition for y, I would just try to plug in y into the first equation. Right, we have x squared plus y squared. Sorry, I think my mic cut out. I was saying we can plug in this definition of y equal to x squared minus a into that first equation. So it would be x squared minus a, the whole thing squared, equals to a squared. And then if I expand this out, I get x squared plus x to the fourth minus 2x squared a plus a squared equals a squared. So obviously these a squares can cancel out, and I'm just left with, if I rearrange things, x to the fourth plus x squared minus 2x squared a is equal to 0. And then I get x to the fourth, and I can factor out that common x squared to get 1 minus 2a. And I hope you guys are following so far, because the next step here would be to factor out x squared again. I guess I could have done that initially, but for me it's clearer to see here that I can factor out an x squared from both of these terms. And I'm just left with x squared times x squared minus, plus 1 minus 2a equals 0. Now the two options here are either x squared is equal to 0, which implies that x equals 0, or x squared plus 1 minus 2a equals 0, which implies that x squared is equal to 2a minus 1. And if I take the square root, that becomes x is equal to plus or minus square root of 2a minus 1. In order for the square root of 2a minus 1 to be valid, because we can't have a negative under the square root for real solutions, right, it says real xy plane, we need the value of 2a minus 1 to be greater than 0. So that implies that 2a is greater than 1 if we add 1 to both sides. And if we divide by 2, we figure out that a is greater than 1/2 is our solution here. A is good. Yeah, and that's exactly answer choice E. I'll paste in the work for that if you guys can't see. I see we got one more question that I will add to the list. Was this a digital SAT problem? Because it kind of looks, or like Khan Academy problem. I'll change our pace for a second here and I'll go over this one. This looks like a nice algebra or algebra 2 problem where we're asked how many solutions does the equation above have. What I can do here is start to factor things out that'll make it easier for me to solve. Like what I can do in the bottom here. I'm going over this one right now. How many solutions does the equation above have? Okay, I'm gonna guess not more than 2 because uh, I've seen these kind of graphs before. Well, let's go over negative. I'm gonna factor out the negative from the top to just give us 2x plus 5 because I don't really like dealing with negative numbers. I'm gonna take a 5x minus 3 here. I'm gonna add from the top here I can factor out 2 times 3x minus 8. And from the bottom here, I can factor out 2, or sorry, even negative 2, and make this also 5x minus 3 equals negative 1/2. Let's do another step, and let's do it in blue to change up the colors. The 2 and a negative 2 here could cancel to just give us a negative 1, and that'll be negative 2x plus 5 all over 5x minus 3. Subtract 3x minus 8 over 5x minus 3. Now that we have the same denominator, it should be a lot easier for us to solve it. So I'm going to combine all the like terms in the numerator and get negative 2x minus 3x minus 5 plus 8 after distributing all of these negatives appropriately, or 5x minus 3. And that means that we get negative 5x plus 3 over 5x minus 3. Right, so we could factor this even further. If I factor a negative from the top, we get negative of 5x minus 3 over 5x minus 3 equals negative 1/2. And that gives us negative 1 because these two things cancel out to 1. Let me do this in a nice color. Negative 1 is equal to negative 1/2. I don't know. How many solutions do you guys think that is? Oh, I see Oliver already answered it 2 minutes ago. And he's right. Because this would mean that, I mean, this is an impossible statement. There's no way this is true. So based on that, we know that there are 0 solutions. If you wanted to verify, you could also graph it out in Desmos just to visually make sure. But yeah, 0 solutions. I have like 3 more AMC problems for you guys. I think this one is one of the easier ones. Each of the following 4 large congruent squares is subdivided into combinations of congruent triangles or rectangles and is partially shaded. What percent of the total area is partially shaded? Total area. Okay. What I would do is literally like take these pieces and start moving them into place in one figure. So I could fill in this, like I could move this square right here, and then this last bar, which is a quarter of this square, is gonna fit right in here. Half of it will go here, half of it will go here. So in essence, when I fill everything up like this, we'll have one square that's fully shaded, and all the other parts that I moved will leave the other squares empty. Since they're all equal, it's literally 1/4 of the squares, or 25% of the total area is shaded. The next one is a little bit more challenging, but if you draw it out like I'm about to show you, it shouldn't be too bad. We have that on an algebra quiz. 10% of the students scored 70 points, 35% scored 80 points, 30% scored 90 points, and the rest scored 100 points. So percentage-wise, let me put it this way. If 10% of students who scored a 70, 35% who scored 80, 30% who scored 90, and the rest scored 100. So that would be 100% minus 10 minus 30. That would give us to 60 minus 35 would bring us to 25%. We want to find the difference between the mean and the median of the students' scores. Let me do median in red and the mean in blue. The median is just the 50th percentile, the middle number relative to all the students, location-wise. If I add up cumulatively from here to here, this encompasses 55% of the data. The people who scored 90 and 100 were 30 plus 25%, so they covered 55% of the data. So of course, the median is going to be somewhere right here, that 50th percentile mark, because from here to here it's only 45. So obviously that 50th percent has to be somewhere like right here. So the median is 90. For the mean, that's going to be a weighted average. So to calculate that, we would need to take the people that scored a 70 and weigh it against that 10%. I'm not going to have space here. Okay, so median is 90. For the mean, we would take the 70 scores of 70, weigh that against the 10%. Score of 80, that would be 35% of people. Score of 90 would be 30% of people. And the people scored 100, that would be 25% of people. And normally you divide by the number of people, or like whatever the total is. In this case, the total is 100%, which if I'm writing as a decimal is just 1. So that's all good. That would make our mean 70 times 0.10 is 7. 80 times 0.35 I think is like 28. 90 times 0.30 is 27, and 100 times 0.25 is 25. So add this up, what do you get? The median is, the mean is 87. So when you're asked to find the difference, you're going to take 90 minus 87 equals 3. That would be answer choice C. And if you guys can't see the screen, just know I am posting a PDF afterwards. And I'll be doing a session recording, so you can ask for that. This is my last AMC problem that I think is the hardest one of today. But it can be expressed quite simply if you're good at expressing words into math. And let me paste it in the chat. David drives home from to the airport. Sorry, David drives from his home to the airport to catch a flight. He drives 35 miles in the first hour, but realizes he'll be 1 hour late if he continues at this speed. He increases his speed by 15 miles an hour for the rest of the way and gets there 30 minutes early. How many miles is the airport from his home? It's tricky, right? The first thing I would do is to know that a rate is equal to a distance over time. I think it's a super useful formula that will help you on the AMC, math counts, SAT, ACT, whatever, or R equals D over T. And then since we're trying to find distance, I can also rewrite this formula as D equals RT, just by some simple manipulations. So I can write two equations here. What I would do is write a distance equation considering his initial drive. He was traveling a distance D. We don't know what distance. That's equal to, let's see. So let me draw it out here actually to make it a little bit more clear. He's driving from his home to the airport. I hope you can tell that that's an airplane. He's driving in the first hour. He goes 35 miles. And then we have the remaining distance d. I could write an equation for this remaining distance d. We know that if we set t equal to the remaining time to get to the airport, d is the remaining distance, t is the remaining time. We could write an equation that relates the distance, the rate at which he travels, and the time. D is equal to 35 miles per hour times t plus 1. Because if he continues traveling at this current rate, the remaining distance that he covers, d, he will do at 35 miles an hour. He will do it in the time that it takes to get to the airport plus an extra hour, because remember, he's going to be 1 hour late. But if he increases his speed by 15 miles per hour, so now he's traveling 50 miles an hour, he would get there in the time to be on time, but also spare half an hour. He would get there 30 minutes early, which is 0.5 hours. So now you have these two equations for the distance. You can relate the distance in terms of his initial travel speed, but you know that he's going to get there late, right, in t plus 1 hours. Or he can travel at 50 miles an hour and get there in t minus 0.5 hours. And combining the two, you can set them both equal to each other because you know that they're both equal to d. So expanding this out, you're going to get 35t plus 35 equals 50t minus 25. And I need to move this down to give myself more solving space. This becomes 50, after we combine some like terms, 15t is equal to 60, or that t is equal to 4 hours remaining. Remember, this is the remaining time, not counting the time that he already traveled. So then d would be equal to 35 times 4 plus 1, or 35 times 5, which is 175 miles remaining. Keep in mind this is the remaining distance, right? We do see answer choice B as 175, but that's not correct. because he has 175 miles remaining. And we're asking how many miles is the airport from his home. So since we solved for the remaining distance, we just have to add in the 35 miles that he drove initially. The total distance that he drove is going to be 35 miles plus the 175 remaining miles that he has to drive, which is going to be 210 miles, which is C. I like that problem. It's a bit tricky. What do you guys think of today's session? That's pretty much all I've got for you. Great. You know, Oliver, I sure know you enjoyed it. We were answering all those questions. I enjoyed it too. If you guys didn't hear my spiel at the beginning, I do have more resources at explore.danstestprep.com, which has my newsletter. I should also be posting my recorded sessions on there pretty soon. Maybe I'll even have like a question submission sort of thing there. But right now I just have my weekly newsletter for SAT tips. I have TikTok, Instagram, YouTube that you guys can watch more videos. And yeah, I'll see you guys next week. Thanks for joining.